Hi everyone, let's start lecture 11 on linear programming. This is the first lecture that we are going to cover prescriptive analytics. Up to this lecture, we had descriptive and predictive analytics. In this lecture, we will learn how can we formulate a decision-making problem in terms of linear programming and then implement that model in R to obtain the optimal solution. We will cover two cases in this lecture, investment management under taxation and gasoline blending. Okay. The prescriptive analytics will be considered as a support tool for decision-making process. So here we are going to build optimization models based on the results and outcomes obtained by the descriptive and predictive analytics, and then we will implement that build optimization model in R or any other optimization software to obtain the optimal solution. Uh, the conditions and constraints of the decision-making problem can be defined uh, by the results obtained by the descriptive and predictive analytics, or we can use predictive models to estimate the parameters to formulate our optimization problem. And we can use the predictive models equations like the regression equation to formulate the objective function or the constraints of our optimization problem. Okay. In lectures 11 and 12, we are going to cover linear programming and integer programming. So in this lecture, we are covering linear programming. Investment management under taxation. In this case, we are going to consider the investment in stock market. Uh, People usually invest in the stock market for possible gains in future, but sometimes they may need to sell a fraction of the shares of stocks they own in order to have some cash in their hand. So anytime that they need to sell a fraction of the stocks, they will face with this problem that which stocks to sell in order to have the required cash and also maintain a strong portfolio of stocks for future. Another issue here is paying the transaction fee and tax on gains. So yeah, anytime you sell a part of your stocks, if you have gains, you need to pay tax on gains. And also you need to pay the transaction fee, and at the same time you need to maintain a strong portfolio for the future. So this is the problem that we are going to consider here to see how can we optimize this decision, that which stocks to sell, how much to sell in order to have the required cash and also maintain a strong portfolio for the future and maybe minimize the costs. Okay, so let's go ahead. Suppose that last year you have purchased 150 shares of 8 stocks. So same amount, 150 for 8 stocks. So now you have 1200 shares in total, right? And this is a list: Yahoo, General Electric, Microsoft, Bank of America, JP Morgan, Cisco Systems, Intel, and Pfizer. Here we have the purchase price. So this is the price that you have purchased the stocks, and this is the current price. So if you're going to sell a part of these stocks, this price would be the selling price. And also we do have the next year price estimate. So here we can have a discussion that what would be the role of predictive analytics here in forming this data for our decision-making problem. We can apply a predictive model to estimate the next year price, right? Yeah, this column, next year price estimate, can be the outcome of a predictive model here. Okay. At any time that we want to sell a part of a stock, a transaction fee of 1 30% of the amount is charged, and also a 30% capital gain tax is applied for any capital gain. Okay, and we would like to sell enough shares to make $10,000 for a down payment. So our decision would be this: which stocks and how many of shares to sell to have the $10,000 after tax and transaction fee. And our objective is maximizing the estimated value of a stock portfolio next year. So our objective here is maintaining a strong portfolio for the next year based on the price estimates, and our decision would be which stocks and how many share of the stocks to sell to gain that $10,000 that we need now. Okay. Now we want to formulate this decision-making problem in terms of a linear programming model. The first thing that we need to do here is defining the decision variables. So here we define a continuous variable, and we showed the variables by the first letter of the stocks. So it would be, for example, Y for Yahoo, G for General Electric, and so on. Okay, so these are continuous, so this would be greater than or equal to 0, and the value of this variable would be the number of shares that we want to sell from that stock. Okay, and for the constraints, we cannot sell more than the shares that we own. That means, for example, for Yahoo, we should have this constraint that Y would be less than or equal to 150, and we will have the same constraint for all stocks. Okay, and for making sure that we will have $10,000, we need to have a constraint for that. So here, for example, for Yahoo, the current price is 31.8, right? So if we can sell this by, we can sell the Yahoo by this price. So this price times Y would be our gross income here. But we need to pay the capital gain tax and also transaction fee. So the tax here would be 30%, so 0.3 times it's applied on the gain. So here we should consider the current price 31.8 minus the purchase price, which is 15.68, and again times Y, right? The number of shares you want to sell. So this would be the tax here, and also the transaction fee is just applied on the gross income, so it would be 0.1 times 31.8 times Y. Okay, so this is just for the Yahoo stocks. So we will have the same for other stocks, and then sum over all these net incomes should be greater than or equal to $10,000. Okay, so this is how we can formulate this constraint here. And for the objective function, we want to maximize this estimated value of stock portfolio for the next year. For example, for the Yahoo stock, the next year price would be 29.5. This is our estimate for the next year's price. So the remaining stocks here for Yahoo would be 150 minus Y, right? And yes, we will have the same for other stocks, like for the GM 26.31 times 150 minus G, and so on. Okay, so this would be our objective function here. So now we have formed our linear programming model. I will have the complete model in the lecture session. Okay, and then we can implement this model in the LP-Solve or LP-Solve API package in R and can obtain the optimal solution. Okay. If you obtain the optimal solution in R, this would be our solution here, selling 150 shares of Microsoft stock and 150 shares of Intel stock and 67.72 shares of Yahoo stock. Okay, and the optimal objective function value would be this. This is our estimate of the value of our portfolio for the next year. So this solution, the optimal solution at the end, we can say it's not somehow a diverse portfolio, right? So we shouldn't be happy with this optimal solution if we are a type of investor that we want to have a diverse portfolio, because we are selling all of our shares of 2 stocks and none of our shares of 5 stocks. So this is not actually this is not helping us to maintain a diverse portfolio. So if we want to have a diverse portfolio, we need to make some changes in our model by adding more constraints, maybe, in order to keep our portfolio diverse for the next year. In order to have a diverse portfolio for the next year, we are going to add a new constraint that we cannot sell more than 75 shares of each stock, or we want to keep at least 75 shares of each stock for the next year. So here we need to modify our model. If you remember, we had this constraint xi, the number of shares of stock I we want to sell. It would be a non-negative variable and also less than or equal to 150, right? So now we need to change this constraint by modifying 150 to be 75, okay? So yeah, by having this modification, we need to solve the model again, and if we do, we would have a new optimal solution. So as see here, in the new optimal solution, we are selling 75 shares of Yahoo, 75 shares of General Electric, 75 shares of Microsoft, 75 shares of Intel, and 75 shares of Pfizer, and just 4.6 shares of Cisco Systems. Okay, so now we have a diverse portfolio for the next year. And the new optimal objective function value would be this, 26,453.21. This is less than the previous one, because since we have a tighter constraint here, so we shouldn't expect to have a higher objective function value compared to the previous one. If we are a type of investor and prefer to have a diverse portfolio for the next year, then this new optimal solution would be preferred over the previous one. But if we just want to have the highest valued portfolio for the next year, then we might prefer the previous solution over this new one. Okay, thank you.